one important wave actually is a sound wave. And a sound wave is basically a disturbance in space that's carried along. So, for instance, if we clap our hands, we create a disturbance that then is, that disturbance is carried, is a wave that's carried along through the air. The air is the medium. So one of the things about sound waves is, unlike light waves, which we are going to talk about, but sound waves require a medium. Light waves don't. For instance, we have this little speaker over here at the right. That little speaker over here is boosting out sound that is actually creating these compressions and rarefactions in the air. So as it turns out, sound waves actually are a type of longitudinal wave, because the waves are being created and moving in the same direction as the energy. I just thought this was cool. Kind of a random little picture, but here's a picture of an ear. It's just amazing then. So here are our little bits of sound, just basically air compressions entering the ear. And I'm not saying I know much, I don't know much at all about it, but there's the little sensitive part, our eardrum, that gets that little membrane starts to wiggle, and then it is amplified by the inner parts of our ear. It is just amazing. Now, I think I mentioned this before, that longitudinal waves, like sound waves, can be represented by a graph like this, where our compressions are high along the y-axis. This is and along the x-axis is distance. And then this would be our rarefaction, and this would be our compression. Yeah, so what else did I want to say? So what we perceive as volume is actually amplitude then. The more intense the compressions, the higher this will be, and it's actually then louder. So that's loudness. And if you take these wavelengths and if you make the wavelengths shorter, okay, so instead of this, making them short, you're going to shorten the wavelength, makes it increase the pitch. Shorter wavelength, the pitch goes up. Yeah, shorter the wavelength, the higher the pitch. The shorter the wavelength, let's do this right quick. I want to kind of emphasize this. I think this is neat. Remember we said that if we take velocity is equal to frequency times wavelength. Okay, now assuming your velocity is going to change, assuming your velocity is going to stay the same, can you see where if you, you make the wavelength smaller? So if you decrease, I'll put SM for small, if you decrease the wavelength, that is actually going to increase the frequency, and vice versa. They have to kind of complement each other in that way.